Hey everybody, this is video 9 on electrolytes. This is a conversation that we started on Parents' Day, so some of this may be familiar. So we've heard about electrolytes, all those sports drinks commercials, Gatorade, Powerade, all that stuff say they contain electrolytes, so they must be important to us, but what are we talking about when we say electrolyte? I guess the easiest way to explain it is to say that electrolytes are ions that exist in water, aqueous solutions. So right here's a illustration of some ions. We can tell they're ions because they have charges and they're floating around in what looks to be like water. So we have some electrolytes here. Now I do want to point something out. Some of these ions only contain one element, like that one. Like that one, that's just calcium. Like that one, that's just sodium. That one's just chloride. There's another one, just calcium. Anyway, some of those just contain one type of element. Some of them contain a different type of element. Like for example, this one has three elements, different elements in there: hydrogen, carbon, and oxygen. This is another one. That one contains sulfur and oxygen, two different types of elements. So what we're dealing with here are all ions because they're charged, but the one that just contains one type of element is called a monatomic ion. Mon meaning one. And the type that contains two types of elements, like that, we call a polyatomic ion, which is really just kind of like a molecule with a charge. So a good question might be, okay, how do these ions get in the water in the first place? Well, often what happens is a solid ionic compound, like say sodium chloride, salt. You can tell it's ionic because it's got a cation, sodium, a metal, and chloride, the anion's a nonmetal, and that's composed. Here's like a crystal of sodium chloride, and it's these alternating sodium and chloride ions. And water itself has positive and negative charges. We'll look at that more closely in the next few slides, but the water molecule just systematically pulls the ions out of the crystal and into solution. So that's how they get there in this method called dissociation, because the ionic compound NaCl dissociates into separate ions. So remember, ionic compound contains a cation and an anion, and that means the cation's usually a metal from the left side of the periodic table, and the anion is usually a nonmetal from the right side. And so here's sodium chloride, what we were just looking at. One little piece of this, one little sodium chloride, one part of this crystal is called a formula unit. And so whenever we write an ionic compound for something like, even if it's like potassium chloride, a grain of that, we're just looking at one, when we write the formula, we're just looking at one formula unit. And like we said, water molecules have positive and negative sides to it. The hydrogen end, represented here by the white blobs, are positive, and then the oxygen end down here is negative. And so that works with the sodium chloride because the positive end is attracted to the negative chloride ions, and then the negative end is attracted to the positive sodium ions. And like that, they systematically pull the sodium and chloride ions out of the crystal and into solution. That's called dissociation. So here's one way we could represent this dissociation. We could say sodium chloride becomes or yields sodium ion and the chloride ion. Notice these symbols here written as subscripts. Those are the phases. So if we start with solid sodium chloride, we get aqueous sodium ions and chloride ions. aqueous means they're in solution. Now you may be wondering, well, why don't we have water? Like, why don't we have water as one of the reactants? And the reason is the water doesn't really react with the sodium chloride to form something new. This is a physical change. It's not a chemical change. These things were ions before, and they're still ions. They're just separate now. So water is not listed as a reactant because it really isn't. This isn't a chemical. This is a physical separation. It's not a chemical where we get something new. First, I want to apologize for this slide here. When it got reformatted, it moved the picture around so you couldn't see what was written, so I wrote it in. But what this is talking about is another way that electrolytes can be produced. A lot of them are produced by ionic compounds like we were just talking about, but there are some covalent compounds or molecules where you have two nonmetals that also produce ions when they're dissolved in water. And these are usually acids and bases. So we're talking about things like hydrochloric acid, sulfuric acid. Notice there's no metals here. And so these are covalent compounds, but they produce ions in solution. So there's a subtle difference between what happens when an ionic compound, like potassium chloride here, and a covalent compound, like hydrochloric acid here, dissolve in water. Now let me be clear, the end product are the same. We get ions put into solution. But the difference is what we start with. With this ionic compound, we begin with ions. They're already positive and negative ions. All that's happening in this process is they're just separating, which we call dissociation. But over here in this molecule, these are not ions. They're sharing electrons. That's what this line in between the hydrogen and chloride mean. They're sharing electrons, but in water, this acid will cause the hydrogen ion and chloride ion to form, and that's a process called ionization because ions are being made when they weren't there before. So that's a subtle difference between the two. So ionic compounds dissociate. Covalent compounds like acids, they ionize when they become electrolytes. And as we saw in class, electrolytes conduct electricity, but they only do so in solution. When we saw the dry salt, it didn't complete the circuit and light the light bulb, but when we put it in water, dissociation occurred, ions can move about freely, carry the current, and complete the circuit and light the bulb. Remember tap water, how it didn't light up the bulb very much? There's a difference between electrolytes. Strong electrolytes they dissociate 100%. So when we put sodium chloride in there, every sodium chloride ion separated. But when you have a weak electrolyte, like for example hydrofluoric acid, not all of it separates into ions. A lot of it stays in the molecular form, and so it's not as good a conductor of electricity. So it ionizes less than 100%. If it's a weak electrolyte, it ionizes 100% if it's a strong electrolyte. Thanks for watching.